So, okay. So, right, we're talking about fractional expressions for the most part. We're going to start off with some domain stuff. And
48.
what was that?
48.
Page 48, yeah, that's where we're at. So 1 to 35 on page 48, 49. This is basically fraction rules. Okay, so if you remember your fractions, then you're probably in a good place. But let's start with the domain stuff. So I'm looking at just number 2, and I'm following this checklist, just like from before. So I think the best way to go through these is just to look at them. And here's how you think about it. So we have this. These aren't really functions because they don't give you the f of x, but this is true for functions as well. When you're talking about domain, which values are we talking about? X, okay? And so when you're asked to state the domain, you're saying, you start with the idea that all real numbers should be allowed to plug into most things. And then right now we're really looking for those 2 situations at the top of the list, okay? So that first situation, so here's the problem we're looking at. So the first situation talked about a denominator with a variable. So is there a denominator with a variable on this one? No, okay. So then the next situation was a variable inside of an even root. Is that happening here? No, so those 2 things aren't happening. So then your domain is going to be all reals.
What do you mean by the even root? You mean like, so if it was like 4x squared.
So an even root, so you can do it that way, or if you really want to be fancy, you can do it this way, right? So even root is square root, or fourth root, or any even number root, okay? All right, so far so good? All right, so then number 4, this one's kind of weird, so I'm going to explain this a little bit. So again, we're going through our checklist. Is there a x or a variable in the denominator? Is there a variable inside of even root? No. So then you start off saying, okay, well then it's all reals. But then they make the statement that they only want you to look at x values bigger than 0. So you start with the idea that it's all reals, but then they're telling you, no, I just want you to look at these. So then your domain on this one is actually the same as that statement. So you're going to say, domain is all reals, provided that x is greater than 0. Not because you're not allowed plugging in negatives, but because they want you to look at only positive ones. Fair enough?
So for number 3 would be all real, x is greater than or equal to 0?
Yeah, so you have to say on number 3 that x has to be greater than or equal to 0. So it's kind of obnoxious. All right. So let's get to a little bit more interesting ones. So number 6. That'll work. All right, is there a variable in the denominator?
Yes.
All right, so then we have to go through that step, and you have it written down. But what are you worried about dividing by?
0.
0. You're not allowed dividing by 0. So then what you're going to do is take any denominator that has a variable in it and set it equal to 0. Because when you do this, you're asking a question. You're saying, what is the x value that will give me 0? That's what that says right there. Now, all you got to do is solve it, so it's pretty easy to solve, right?
0.5.
So yeah, so then well, close anyway.
Negative.
So that's the value, if you plugged in, would give you a 0 in the denominator, which is what you're not looking for. Or like, that's what you don't want. I mean, that is what you're looking for, but that's what you don't want. So then you're going to say, well, the domain then is all reals except for that one that I just found. Okay? Now, there could be more than one answer when you do this, so you got to list them all out that work. All right? So again, if there's nothing in the denominator, there's nothing in a root, it's going to be all reals unless they say some other statement. If there is something in the denominator, you set it equal to 0. That's what it cannot be. All right? So number 10. Okay.
And we jump 7.
So number 10, 1 over the square root of x plus 1. So this one's kind of a tricky one because we haven't talked about the square root yet. So just square roots, what are you not allowed to take an even root of?
Negative.
You can't have a negative. So if it's inside a radical, an even root, it can be a bunch of things as long as it's not negative. So what you would say is, you know what, I want that inside has to be bigger than or equal to 0. And then you solve that. And that's what it is, which is different.
So it equals to that.
So now this one's kind of weird. So if it's just a square root in the numerator, you do it this way. However, you can't have 0 because you're allowed to take the square root of a 0. But then in this one we're down in the denominator, so we actually have to say that it can't be equal to 0 because again we'd be dividing by 0. Does that make sense?
Yeah.
So then
X has to be greater than -1.
so x has to be greater than -1, and that is actually your domain. Okay, so slightly different. When you solve this one, those are the numbers that provide your domain. When it was just a denominator, that's what it's not allowed to be.
It's not all real numbers.
So I kind of ran out of room. So yeah, I mean, really, if you write this, that's fine. So you could also write all real numbers so long as x is greater than -1. Hey, what's up, Mike? All right, so everything's okay. Is that okay?
Yeah. So for number 9, we don't have to set that up because there's no variable in the denominator.
So then you're going to set number 9 greater than and equal to 0 because it's allowed to be 0.
Okay.
So I know that's a little,
Because that's the numerator, basically. Technically.
because it's in the numerator, and so you can have a 0 in the numerator. Yeah, right.
So x is greater than or equal to. Yeah.
So every once in a while it's a domain, so you can't just forget about domain. It ends up being important. All right, so let's go back, way back, to simplifying fractions. How do you simplify that?
Divide by 2.
Why are you dividing by 2?
If it's like,
You have like this common factor between those two.
There's a common factor, and ideally you get the greatest common factor between those two, right? And so then everyone should be right, everyone's relatively happy with this, right?
Yep.
Okay, so that's kind of a shortcut, and they don't want to overwhelm you when you first see these, because I think it's in 4th or 5th grade when you guys first see these, yeah?
Yeah.
So somewhere. So they just say divide by the biggest thing. But really, I'm going to show you stuff, and I'm not saying that you have to do it this way. This is just why this works and why what the notes work and how you're going to do these other problems. Okay? Would it be okay if I said that 4 over 6 is the same as this?
Yeah.
yeah.
Right? And then would it be also equally okay if I said then really that's the same as this?
Yeah.
Right? And then everyone realizes that anything divided by itself is just 1. And so then you could really say that this is going on, which really gets us to 2 over 3, right?
Yeah.
So that's really more what you're really doing. They just shortcut it for you so they don't overwhelm you when you're first learning this. But the idea, this is the important step right here, is that we actually factored out the common factor. And then we're allowed to cancel those out because of all this stuff over here. And so then that's how we get to the 2 over 3. Is that okay? All right, so then let's look at 12, 14, let's just do 12. Let's just do 12.
That just seems easy to me.
Well, good, because you're going to get a lot of it. So here's what's going on with 12.
Or it could be completely wrong.
Well, I don't know. Oops, that's not even right. That's supposed to be a 3, isn't it? Right, so that's a 3 over 4, and then a 3, and then we don't know, and then a 4, and an x plus 1. All right, so yeah, so what they're saying is, we're starting on the right, it's already been factored for you. Something got canceled and we're left with 3 over 4. So you're looking for what is it that ended up getting canceled so that you're left with 3 over 4? Right, so then x plus 1.
So it is exactly right.
Yeah, good. Is that okay? So that's what that section's about.
Yeah.
All right, so then let's jump down to 20, and we're just going to go through those steps that I had, okay? All right, so 20, 9x squared, 9x, 2x plus 2. All right, now, the very, very, very most important part of this set of steps is that you must factor first. All right, so you guys that I had last year, right, you remember how I would get to the no, like with the exclamation marks? Right? Yeah, okay, well, yeah, okay. But like you guys that were like the no, because like you're doing something super bad. Like it's not like you're making a mistake, you're not thinking, it's just bad. So no's are like bad, don't do this, please don't do this again, okay? So if you don't factor first, you're gonna get a bunch of no's on your paper. Okay, and so every year I do this, I warn people ahead of time, please factor first. Only cancel factors. And then someone will go through and just start hacking things out. And then they'll get the no, okay? So don't do that. So factor first. So, right, you got to go through all your steps of factoring, which include greatest common factor. So is there a greatest common factor in the numerator?
Yeah, 9x.
9x, okay, and so then what's left over?
X plus 1.
Is that okay with everybody?
There's an x plus 1 at the bottom.
Because the greatest common factor down there is...
X plus 1.
All right, now you should always check, right, before we go on, right, can you factor anything else here? No, you can't. Okay, so then only factors are allowed to be canceled, right? And so just to, put a finer point on it. A factor is 9, a factor is x, and a factor is x plus 1.
Yep.
A factor is 2, and a factor is x plus 1. Not not inside, just like big things, right? So then what can we cancel?
X plus 1.
Yeah, there's x plus 1s. Can we cancel anything else, or can we simplify 9 over 2 at all?
No.
No, so then what you're saying is 9x over 2. That's what we're saying our
So
answer.
like if it was a 10x on the outside on top, would you be able to simplify the 2 and take out?
Yeah, right. So your job is to simplify as far as possible.
Okay.
So yeah, so maybe we'll get one, I guess not. But yeah, so yeah, you got to look for that kind of stuff.
Alright.
All right? All right, I'm going to do also 22 for a very specific reason. So hold on.
Yeah, you can't choose minus 25.
Right, don't do that. All right, so let's look at 22. So x squared minus 25 over 5 minus x. All right, so again, we're talking about factoring. So looking at the numerator, is there a greatest common factor? No, there's two terms, so you better be looking at difference of squares or difference of cubes.
Different square.
Difference of squares. So then the numerator factors into what?
X
X plus 5, x minus 5.
Is there anything we can factor in the denominator?
No.
No. So, do we have common factors that we can cancel?
No.
No, but, right, because they need to be exactly the same. But, if you look closely, and this is something that you got to look for, and like you guys are at a level of math, like this is the first time I'm saying this to you guys, I think, anyway. Right? You're not going to know everything, and then all of a sudden I'm going to show you a little trick, and then you're going to be like, oh, okay, fine. But then you got to remember that little trick, okay? So if you look closely, we have a positive 5. I'm looking at the denominator. Right? We have a positive 5 and a negative x. And then up here we have a positive x and a negative 5. So the signs are exactly opposite. So we can factor out a negative 1.
Oh, yeah. I was about to say.
All right, so then, right, then we're going to have x plus 5, x minus 5, and then I'm going to take out a negative, and is it okay that we now have this x minus 5 there?
Yeah.
Right? So it is important because that negative sign is now floating around. But now we do have common factors that we can cancel, one in the numerator, one in the denominator.
So there's a negative sign going outside of x plus 5.
So yeah, so I would just put it right there. I mean, you're welcome to distribute it if you want, but like I would just throw it out there.
Would it have to be, oh, no.
Is that okay?
It'd be over -1.
You could leave it over -1, that's also fine. Right, because you can put your negative in different places in the fraction and it's fine. All right, I'll do one more. Anything from like 24 to 30.
0, 20, let's just do 20.
I'd say 27.
Which one was good?
Something like just equals.
Yeah, let's do an even one. Well, so how about, yeah, any, whatever you guys want to do. Or we can do an odd one, I guess, that's fine. But like, let's not do 27, let's save that one for like your enjoyment later.
And that's why I wanted to do 27.
Yeah, well, that's why I want you to just save it for, you know, what else, you know, tonight when you're in your room, you can get super happy.
Well, I'm in my room, I'm not doing math, I'm sleeping.
Sure, he's sleeping.
You mean you're texting everybody?
Yeah.
28, we're doing 28.
I wish.
Try and get caught by Eli.
Don't make them mad.
I haven't been,
We're already beyond.
I haven't been doing nothing, no one's just saying,
Alright,
I'm not the one that came up with the idea.
What?
again, you need to be able to factor anything that's thrown at you. So numerator, what can that be factored into?
Difference of cubes.
No.
Not cubes, difference of squares.
Difference of squares, okay, so then what is it?
X minus 3, x plus 2.
Is that okay with everybody? That's supposed to be a 3.
I don't know. And would the bottom be,
Alright, so here's your steps again, right? Always greatest common factor, and then you're counting terms. If there's 2 terms, difference of squares, difference of cubes, sum of cubes. If there's 3 terms, A times C. If there's 4 terms, right, then we gotta look for things like
here's factor, 2 terms?
grouping them.
Yeah.
And so you should always try grouping the first 2 and the last 2.
X squared.
So then it's just greatest common factor. So you say, okay, I'm gonna take an x squared out here. What's left over?
X plus 1.
X plus 1.
Negative 9. X plus 1. So that'd be x squared minus 9 and x squared plus 1. Not x squared. X plus 1.
Alright, so since we factored this x squared minus 9 already, we might as well square, you know, right? Like, does it make sense that then we're left with x plus 3,
X minus 3.
x minus 3, and x plus 1? Is that okay with everyone?
Yeah. So would the x plus 3 and x minus 3 cancel out?
So then every like factor that's in a numerator and denominator can be canceled. So then that x plus 3 and that x plus 3, that x minus 3 and that x minus 3,
There's just one over
there's nothing else. Yeah, so something has to be up there, right? So you have to have a 1 still. So then your answer is going to be 1 over plus 1. Is that right?
Yep.
All right, so 1 to 35 odd. You got the rest of the time to do those.